Hello and Assalamualaikum. My name is IRNIEDA FARISYA binti RAZALI from DDT3B and my matrix number F2019, and I want to explain how to configure IPv4 and IPv6 static and default router. Okay, and this is a table for IP address to configure IPv4 and IPv6 static and default router. Okay, and part 1, configure IPv4 static and faulty static default router. The PT network requires static router to provide the internet access to the internal LAN user through the ISPs. In addition, the ISP router requires the static to reach the internal LANs. In this part of the activity, you will be configuring an IPv4 and static default router and faulty default router to add a redundancy to the network. Okay, step 1, configure an IPv4 static default router. On edge router, configure the director connected IPv4 default static router. This primary default router should be the true router ISP1. Okay, this is the command for edge router. En config T, and then we'll put IP router 0.0.0.0.0.0.0.10.10.10.10.1. Okay, step 2, configure an IPv4 faulty static default router. On edge router, configure a direct connector IPv4 faulty static default router. This default router should be the true router ISP2. It should have a administrative distance of 5. Okay, this is command for how to configure IPv4 faulty static default router. Okay, IP router 0.0.0.0.0.0.0 10.10.10.10.10.5 and 5. Okay, and part 2, configure IPv6 static and faulty static default router. In this part of the activity, you will be configuring IPv6 static default and faulty static default router for IPv6. Step 1, configure an IPv6 static default router. On edge router, configure a next hop static default router. This primary default router should be the true router ISP1. Okay, we're using the command for IPv6 router $.0.0.2001.a.a.1. Okay, and step 2, configure an IPv6 faulty static default router. On router edge router, configure a next step hop IPv6 faulty static default router. The router should be via router ISP2. Use an administrator distance of 5. Okay, and the command is IPv6 router $.0.0.1.dba.a.2.15. Part 3, configure IPv4 static and faulty static router to the internal LANs. In this part of the lab, you will configure the static and faulty the static router from the ISP router to the internal LANs. Step 1, configure IPv6 static router to the internal LANs. On ISP1, configure a next hop IPv4 static router to the LANs 1 network through the edge router. Okay, this command en config T, and put IP router to 192.198.10.16.255.255.255.255.254 and 10.10.10.10.2. Okay, on ISP1, configure a next hop IPv4 static router to the LAN 2 network through the edge router. Okay, ISP1 put IP router 192.198.11.32.255.255.255.254 and 10.10.10.102. Okay, Okay, and step 2, configure IPv4 plotting the static router to the internal LANs. On SP1, configure directly connective plotting the static router to LAN I through the ISP2 router. Use the administrator distance of 5. Okay, insert the IP router for the common 192.168.10.16 and 255.255.255.255.240 and G0/05. Okay, and on ISP1, configure a directly connecting floating static router to LANs to through the ISP2 router. Use an administrator distance of 5. Okay, and insert the IP router 192.168.1.1.32. And IP submit mask 255.255.255.254 and G0/05. Part 4, configuring IPv6 static and faulty static router to the internal LANs. Step 1, configure IPv6 static router to the terminal internal LANs. On ISP1, configure a NetHub IPv6 static router to the LANs network through the X router and insert the command IPv6 router 2001.10.10.6/64 and 2001.db8.a.1.2. Okay, on ISP1, configure a NetHub IPv6 static router to the LANs to network through the X router. Okay, insert the IPv6 router 2001.db8.1.11/64 2001.db8.a.1.2. Step 2, configure IPv6 faulting the static router to the internal LANs. On ISP1, configure a NetHub IPv6 faulting the static router to LANs 1 through the ISP2 router. Use the administrative distance of 5. Okay, insert the IPv6 router 2001.db8.1.1.10.64 2001.db8.f.f.25. On ISP1, configure a NetHub IPv6 faulting the static router to the LAN 2 through the ISP2 router. Use the administrative distance of 5. Okay, insert IPv6 router 2001.db8.1.1.11/64 2001.db8.f.f.25. Okay, if your configuration has been complete correctly, you should be able to pin the web server from the host on LAN 1 and LAN 2. In the addition, if the primary router link is down, connectivity between a LAN host and the web server should be still exists. Okay. Part 5, configure host router. User on the corporate network requirement access a server that is owned by an important customer. In this part of the activity, you will configure the static host router to the server. On router will be faulty static router to support the redundant ISP connection. Okay, step 1, configure IPv4 host router. On Edge router, configure an IPv4 directly connect the host router to the customer server. Okay, insert the command in Edge router IP route 198.0.0.10 255.255.255.255.255.5 serials 10/0/1/00. On Edge router, configure an IPv4 directly connecting the faulting host router to the customer server. Use the administrative distance of 5. Okay, insert the command 8 router IP route 198.0.0.255.255 series 10/0/1/5. Step 2. Configure IPv6 host router. On the 8 router, configure an IPv6 next host router to the customer server through the ISP1 router. Okay. Insert the command in the 8 router. IPv6 router 2001.dba.f.f.10/128 and 2001.dba.a.1.1. Okay, and on the router, configure an IPv6 directly connected faulty host the router to the customer server through the ISP2 router. Use the administrative distance of 5. Okay, and insert the command and add router IPv6 router 2001.dba.f.f.10. Okay, and /128.0.dba.a.2.15. And that's all for me. Thank you for your attention, and the next class I will pass to MASTURINA HUSNA. Thank you.
Thank you, IRNIEDA FARISYA. My name is MASTURINA BINTI MUSTAFA. My matrix number F2005. I will continue our presentation. Task 2, HSRP configuration guide. So this is a topology for HSRP for configuration guide. So next, this is addressing table. Dalam addressing table ni akan ada router 1, router 2, router 3, internet, HSRP virtual gateway, S1, S3, PCA dan PCB serta web server. Dalam semua device ni diberikan IP address dan default gateway serta interface. So untuk objektif task 2 ni, in this practical activity, we will learn how to configure hot standby router protocol HSRP to provide redundant default gateway device to host on LAN. After configuring HSRP, you will test the configuration to verify that hosts are able to use the redundant default gateway if the current gateway device becomes unavailable. So ada dua, iaitu configure and HSRP active router dan configure and HSRP standby router. So part 1, verify connectivity. So dalam step 1, kita kena trace part to the web server from PCA. So dalam kita punya PCA tu, kita buka command prompt. Lepas tu soalan ni, trace the part from PCA to the web server by executing the tracer 209.165.200.226 command. So this is bila kita trace pakai tracer ni, okay, kita akan dapat jumpa IP address dia lah. So soalan dia, which device are on the path from PCA to the web server? Use the addressing table to determine the device name. So dalam R1, R2 dan internet, INET. Okay, untuk step kedua, trace the path to the web server from PCB. So repeat the process in step 1 from PCB. So dalam PCB pula kita akan buat tracer 209.165.200.226. So bila kita dah trace, soalan dia, which device are on the path from PCB to the web server? So dekat sini kita boleh tengok IP apa yang melalui addressing table yang diberi tadi. So R3, R2 and internet INET. Dalam step 3 pula, observe the network behavior when router 3 becomes unavailable. So soalan dia A, select the delete tools from the packet tracer tools bar and delete the link between R3 and S3. So dalam topologi, kita kena delete dia punya kabel antara switch 3 dengan router 3. So next, soalan B, open a command prompt on PCB, execute the traced command with the web server as the destination. So dalam PCB ni kita try trace balik dia punya IP selepas dah delete kabel dari S3 dengan router 3. So dekat sini dia tak boleh trace sebab kita dah delete kita punya kabel tu. So maksudnya dia punya paket tu tak sampai. So soalan C, compare the current output with the output of the command from step 2. What are the result? So the traced command cannot determine the path to the web server because the path has been broken. So yang soalan D, click the connection icon in the lower left corner of the PT Windows. Locate and select the copper straight through icon in the palette of connection types. So kita masukkan balik kabel dekat switch 3 dengan router 3. Dia akan jadi apa? So soalan E, click on S3 and select port gigabit Ethernet 0/2. Click router 3 and select port gigabit Ethernet 0/0. After the lights on the connection are both green, test the connection by ping the web server. The ping should be successful. So kita dah try ping 209.168.200.226. So dia akan reply lah. Okay, next for part 2, configure HSRP active and standby routers. So in step 1, configure HSRP on router 1. Untuk soalan A, configure HSRP on the gigabit 0/1 LAN interface on router 1. So dalam router 1 tu kita akan configure HSRP dalam gigabit 0/1. Kita akan masukkan interface G0/1. So soalan B, specify the HSRP protocol version number. The most recent version is version 2. So kita akan masukkan dekat sambung balik yang configure tadi, standby version 2. So C, configure the IP address of the virtual default gateway. This address must be configured on any host that require the service of the default gateway. It replaces the physical interface address of the routers that has been previously configured on the host. Multiple instance of the HSRP can be configured on a router. You must specify the HSRP group to identify the virtual interface between routers in a HSRP group. This number must be consistent between the routers in the group. The group number for this configuration is 1. Dalam router 1 ni, kita masukkan standby 1 IP 192.168.1.254. So for the question D, design the active router for the HSRP group. It is the router that will be used as the default the gateway device unless it fails or the path to it become inactive or unusable. Specify the priority for the router interface. The default value is 100. A higher value will determine which router is the active router. If the priorities of the routers in the HSRP group are the same, then the router with the highest configured IP address will become the active router. So dalam router satu ni kita masukkan standby 1 priority 150. So R1 will operate as the active router and traffic from the two LANs will use it as the default gateway. So question soalan E pula, if it is desirable that the active routers resume that rules when it becomes available again, configure it to print the device of the standby router. The active router will take over the gateway role when it becomes operable again. So dalam soalan ini kita masukkan standby 1 prem. So soalan dia, what will the HSRP priority of the router 3 be when it is added to HSRP group 1? So the answer is 100 because which is the default value. So gambar yang di sebelah kanan adalah configuration untuk dalam router 1. Bila kita dah configure dalam router 1 ni, dia akan active lah HSRP dengan standby router. So untuk step 2 adalah configure HSRP on R3. Configure R3 as the standby router. So question A adalah configure the router 3 interface that is connected to LAN 2. Repeat only step 1B and 1C above. So maksudnya dekat dalam step ni, step B dengan C kita akan repeat dekat dalam router 3. So dalam router 3 adalah configuration, masukkan dalam privilege mode. Lepas tu interface G0/0, masuk standby version 2, standby 1 IP address, masukkan IP address 192.168.1.54 untuk router 3. Lepas tu kita enter je. So next adalah step 3, verify HSRP configuration. Soalan question A, verify HSRP by issue the show standby command on router 1 and router 3. Verify the values for HSRP rules group, virtual IP address of the default of the gateway, permission and priority. So bila kita masukkan dalam router 1 and router 3, kita masukkan show standby. Lepas tu kita boleh tengok dia dalam group 1, version 2. Dalam router 1 adalah state active. Virtual IP address dia adalah 192.168.1.254. Lepas tu dia diberikan dengan MAC address 0000.0C9F.F001. Sampai situ dia adalah presentation dia enable active router. Router 1 ni adalah standby router dan priority dia adalah 150. Untuk router 3 adalah dah masukkan group 1 version 2. State dia adalah standby. Kalau kat sini dekat router 1 ni adalah state dia adalah active. So dalam virtual IP address dia adalah 192.168.1.254. Dia punya MAC address pun adalah sama dengan router 1. Lepas itu presentation dia adalah router 3 disable, active router dia 192.168.1.1, priority dia adalah 100. Next, soalannya adalah using the output show, answer the following question. Which router is the active router? So slide sebelah ditunjukkan active router adalah router 1. So dalam ni adalah jawapannya adalah router 1. So next soalan adalah what is the MAC address for the virtual IP address? Jawapan dia adalah 0.0.c9f.f001. MAC address router 1 dengan router 1 adalah sama. So next question, what is the IP address and priority of the standby router? The answer is the IP address is 192.168.1.3 and the priority is 100. So for the question B is use the show standby brief command on router 1 and router 3 to view an HSRP status summary sample output. Yang atas ni adalah untuk router 1. So router 1 ni aktif. Dia punya standby IP adalah 192.168.1.3. Virtual IP adalah 192.168.1.1. Dia punya priority dia adalah 150 untuk router 3. Okay, untuk router 3 show standby brief. So router 3 tadi interface kita masukkan dalam gigabit 0/0 group 1, priority dia adalah 100, state adalah standby, active IP adalah 192.168.1.1, virtual IP dia adalah 192.168.1.254. Next, change the default gateway address from for PCA, PCB, switch 1 and switch 3. Okay. Dalam gambar ni kita dalam gambar ni saya letakkan IP untuk PCA, PCB dan switch 1, switch 3. Dalam ni saya ubah default gateway saja. So which address should you use? So dalam ni saya akan gunakan 192.168.1.254. Verify the new setting issue a ping from both PCA and PCB to web server. The ping successful. So jawapannya adalah yes. So next dalam part 3, observe HSRP operation. So step 1, make the active router becomes unavailable. Open a command prompt on PCB and enter the command tracer 209.165.200.226. So soalan dia adalah does the part differ from the part used before HSRP was configured? So the answer is yes. The path now passes through router 1 instead of router 3. So dalam gambar ni, bila kita dah trace dia, adakah IP tu masuk dalam router 1 and router 3? So maksudnya dapatlah selepas kita dah trace IP dia. So untuk step 2, break the link to router 1. So soalan 1, select the delete tools from the packet tracer toolbar and delete the cable that connects R1 to S1. So dalam soalan ini dia akan delete router 1 dan router 2, router 1 dan S1. Lepas tu soalan B, immediately return to PCB and execute the traceset 209.165.200.226 command again. observe the output the command until the command completes execution. You may need to repeat the trace to see the full path. How was this trace different from the previous trace? Okay, for the first, the trace time out. Eventually, the trace went throughout R3, R2, and Internet INET. R3 was used as the first hop gateway, and this trace instead of R1. So, bila kita dah ni, kita dah trace dia, kita buat kita tengok balik dekat dalam router 3. Dia punya ni lah, standby dia, active router dia, IP MAC address dia, semua tu lah. So for the part last, step 3, restore the link to R1. Reconnect R1 to S1 with a copper straight through cable. So dalam router 1 dan switch 1 ni, kita akan bagi balik, masukkan balik kabel copper straight through dalam S1 dan R1. So soalan B, execute a trace from PCB to web server. You may need to repeat the trace to see the full path. What the path is used to reach the web server. So jawapan dia waktu first kali dia akan fails. Bila dah trace balik lagi semula, dia jadilah. So if the bin command was not configured for the HSRP group on router 1, would the result has been the same? Tak, sebab router 1 tu not become the gateway again. The path through R3 would continue to be used. So ini adalah kita punya, bila kita trace, ini adalah topologi yang selepas disambungkan kembali. Itu sahaja daripada saya. Untuk task 3, saya akan serahkan kepada teammate saya. Sekian, terima kasih.
Terima kasih MASTURINA HUSNA atas perbincangan task 2 itu tadi. Seterusnya saya, Nilam Sari binti Hasan BASRI, matrix number is F2009, akan menerangkan task 3 PMITI untuk configure Dynamic Host Configuration Protocol DHCP before mengikut topologi dan alamat IP yang diberikan seperti dalam gambar raja di atas. Okey, macam mana kita semua tahu, perkhidmatan DHCP ni adalah untuk membekalkan alamat IP yang tertentu kepada komputer klien DHCP secara automatik dalam tempoh yang diberikan. Komputer klien ni akan menghantar broadcast IP kepada server DHCP untuk meminta alamat IP. Server DHCP menerima permintaan dan akan memberikan satu alamat IP yang belum digunakan bagi satu tempoh yang tertentu. Okay, untuk part 1, configure a router as a DHCP server. Step 1, configure the excluded IPv4 address used to exclude a certain IP address from being assigned to DHCP client by the DHCP server service on a Cisco iOS device. For this scenario, this task, addresses that have been statically assigned to device in the networks that will use DHCP must be excluded from the DHCP pool. This avoid the error assigned with the duplicated IP address. In this case, the IP address of the R1 and R3 LAN interface must be excluded from DHCP. In addition, 9 others addresses are excluded for static assignment to others device such as service and device management interface. The format of the command is IP DHCP excluded address, start address, and address. Okey, untuk soalan A, configure R2 to exclude the first 10 address from the R1 LAN. Kita perlu masukkan dalam R2 mode config, masukkan command IP DHCP excluded address 192.168.10.1 dengan akhir IP addressnya 192.168.10.10. Untuk soalan B, kita perlu configure R2 untuk R3 LAN pula dengan format yang sama, dengan IP dengan command IP DHCP excluded address 192.168.30.1 dengan IP akhirnya 192.168.30.10. Untuk step 2, create a DHCP pool on R2 for the R1 LAN. DHCP pool ni adalah protokol rangkaian yang membolehkan pelayan ni memberikan alamat IP secara automatik kepada peranti yang ditentukan daripada julat nombor dia sendiri. Okey, yang the first, kita kena create a DHCP pool name R1 LAN. Okey, masukkan kepada router 2 dalam mode config, masukkan command IP DHCP pool R1 LAN. Seterusnya, kita perlu configure the DHCP pool to include the network address, the default gateway and the IP address of the DNS server. Kita perlu masukkan dalam mode DHCP config, masukkan command network 192.168.10.0 dengan subnet mask 255.255.255.0. Seterusnya diikuti dengan command default router 192.168.10.1 dan kita perlu masukkan DNS server 192.168.20.254. Seterusnya kita perlu ulang langkah yang sama kepada R2 untuk R3 LAN pula dengan koman yang sama menggunakan koman IP DHCP pool R3 LAN dan seterusnya diikuti dengan koman network 192.168.30.0 dengan subnet mask 255.255.255.0 dengan koman default router 192.168.30.1 dan seterusnya dengan koman DNS server 192.168.20.254. Next, part 2, configure DHCP relay. A DHCP relay agent is a host or router that forwards DHCP packets between client and server. Step 1. Configure R1 and R3 as a DHCP relay agent. For this scenario, this task, for DHCP clients to obtain an addresses from a server on a different LAN segment, the interface that the clients are attached to must include a helper address pointing to the DHCP server. In this case, the hosts on a LAN that are attached to R1 and R3 will access the DHCP server that is configured on R2. The IP address of the R2 serial interface that are attached to R1 and R3 are used as the helper addresses. DHCP traffic from the host on the R1 and R3 LAN will be forwarded to these addresses and processed by the DHCP server that is configured on R2. Untuk langkah pertama, kita perlu configure the helper address for the LAN interface on R1. Kita perlu masuk kepada R1 dalam mode config dan kita perlu masukkan kabel interface G0/0. Seterusnya berada dalam mode config if, masukkan command IP helper addresses 10.1.1.2. Kita buat langkah yang sama untuk configure kepada R3 juga. Next, configure the helper address for the LAN interface on R3. Kita pergi kepada router yang ketiga, berada dalam keadaan mode config. Masukkan kabel interface G0/0. Seterusnya, masukkan command IP helper address 10.2.2.2. Seterusnya, untuk menyemak, configure host to receive IP address information from DHCP kita berjaya ataupun tidak. Kita pergi ke PC 1 dan PC 2 telah menerima IP address daripada DHCP yang telah kita configurekan tadi, berjaya ataupun tidak. Di sini berjaya, telah kita masukkan DHCP request successfully dan kita perlu menyemak IPv4, snapmap mask, default gateway dan DNS server yang telah kita masukkan itu tepat dan betul berdasarkan address table yang telah diberikan. Part 3, configure a router as a DHCP client. An interface on a router that connects to the Internet Service Provider ISP is often configured as a DHCP client. For this task, Part A, configure the gigabit internet 0/1 interface on R2 to receive IP address from DHCP and active the interface. Kita perlu berada pada router yang kedua, mode config, masukkan interface G0/1 dan seterusnya masukkan command IP address DHCP dan masukkan command no shutdown. Seterusnya kita boleh nampak gambar raja di sebelah. Semua kabel telah hijau dan di sini terdapat semua paket telah menerima data dengan baik. Dan seterusnya kita masukkan command show IP interface brief. Di sini kita dapat lihat gigabit internet 0/1 dengan IP address 209.165.200.231 berada dalam keadaan yes, DHCP up, status up, method protocol up dan method DHCP. Next, for the last part 4, verify DHCP and connectivity. Step 1, verify DHCP bindings. Kita perlu berada kepada router yang kedua, masukkan command show IP DHCP binding. Di sini kita dapat lihat details hardware address yang dipaparkan. Seterusnya, step 2, verify configuration. Di antara PC 1 dan PC 2 ni kita dapat ping antara satu sama lain. Di sini kita masukkan kepada PC 1, masukkan command ping 192.168.30.11 reply. Di sini status successfully. Sekian sahaja daripada ahli kumpulan kami dalam perbincangan problem based task routing essential. Thank you very much for your listening.